Hello there YouTube. Today I'm going to explain to you the two most common types of wire feed welders, MIG and Flux Core. They're basically the same thing with subtle differences. I'll start by explaining MIG, how MIG works. Now with MIG, you have a gun or a stinger. I don't know the technical name for it. That's just what I call it. Now, you have with every welder the ground clamp. Now, when you start welding with MIG, as you can see, there's wire in there. The wire will come out and it'll hit the metal and create an arc, and it'll start melting the metal together. The wire also works as a filler, and out from around this little dark circle comes gas. And the gas, what it does, it pushes the oxygen away from the weld, because if oxygen gets inside the puddle, it creates porosity, which is basically just a bunch of little holes inside the metal or inside the weld, and it'll make it weaker. That's basically MIG. I've heard MIG welds a lot cleaner than Flux Core does. It's smoother, and it doesn't produce as much slag, I'm just going to say. So, before I get into explaining Flux Core, I'm feeling like putting in a dip. So, let's do that. Some good old Copenhagen straight. Alright, I'm back. Now, the way Flux Core works. Flux Core is basically the same as MIG. It's a wire feed. If you open up the little hatch on the side of the Flux Core welder, it's going to be the same looking on the inside as it is with a MIG, except you won't have the gas line or none of that crap. Now, Flux Core, you use different types of wires. The wire with Flux Core you use, I like to use 30 thousandths of an inch. And that's actually what this welder is Flux Core. It's a little 110 volt Flux Core welder. And you can't really tell, like, at all. If I get my face out of the shot, it might focus on it. No, you really can't tell, but inside the middle of the wire is flux. And what that does is when you weld, you hook your ground clamp up to the metal, then once you put your stinger down, the wire comes out and the metal in the wire creates the arc. The flux in the middle of the wire covers the puddle to prevent oxygen from getting inside the puddle, therefore preventing porosity, which makes good welds. Now, I don't have a MIG welder on hand. Where I work, I do have MIG welders, but here I only have the Flux Core. So, I'll be doing some demonstrations on welding with Flux Core, because that's something that I found very tricky whenever I first started welding. Before I started working where I am now, I just kind of did no welding at all. Every once in a while I'd try to weld something just to practice at it. Since I started working, I've gotten a lot better at it. I don't even know how, I just have, just practice. And that's one thing about welding, is in order to get good, you can't just watch this video or any other video on YouTube and then be good at it. You have to learn how to do it, and you also have to practice. Practice is a lot. My boss tells me all the time, I can teach anybody to weld in 5 minutes, the rest is practice. So I'm going to demonstrate some welding to y'all now. Alright, now let's try to get us some welding done. Let's see. I'll show y'all what I got the phone in right now because I just made it before the video started. I can't really tell. Yeah. I'll weld right here anyway. Yeah, try to give y'all a way to see. Now, the number one thing you need for safety is a welding helmet. I like these because these are a lot cheaper and the screens are darker. The screens are darker than what the automatic ones get, and also you don't have to worry about replacing the batteries whenever they run out, because it has no battery. Now, one of the ways I've noticed when you're welding with one of these helmets, best way to do it is learn to flip the helmet down. Sorry, I had an alarm there, but you got to flip the helmet down. And you can also open up that flap to see, you know, if you forget where you're at or something. So I'm going to demonstrate some welding to y'all now. Oh, before I start, another safety thing that it depends on who you're talking to as to whether it's needed. Gloves. I like gloves because they help prevent you getting burned, but the downside to them is MIG gloves are so thick you can't really do anything. Now you can get thinner MIG gloves, but I didn't see them at TSC, and the gloves I got were MIG welding gloves. They're fairly thick. They're like cowhide, some crap like that. So I can weld with or without gloves. Now you hook your ground clamp up to your metal. You got to make sure, you got to make sure the metal's clean, or else you'll get little holes in it. That's not porosity, but you will get, it's not porosity caused by oxygen, but you'll get like 1 or 2 little holes in the weld if your metal's not clean. Just tiny little like pinhole type holes. And another thing you got to make sure of, it's got to be clean so you get a good ground and you can get a good arc. I'll demonstrate what happens when you don't get a good arc or ground. If you don't get a good ground or arc, you know, because you got something on the metal, usually it won't start an arc at all. So I'll try to demonstrate that now. Now, as you can see, this is my exhaust. So the way exhaust pipe works is it's galvanized. Well, you grind the galvanization off of it and you weld it. Well, then the welds get rusty. So I got some of this galvanization paint. It's not really paint, it's just kind of like spray galvanization. Zinc coating is what it is. I got some of that sprayed on there so my welds wouldn't rust. Now this, I got a different exhaust on my truck now. I got a straight pipe to a side exit in front of the rear passenger wheel. You know, I sprayed the galvanization on there too. But as you can probably tell by the wire, it didn't start an arc. So now I'm going to demonstrate to you getting a good arc, a good ground, or, you know, the metal's clean so you can weld good. Let's see. Oh, and a little trick, if your wire's too long, you just put it on the edge of your metal like so. Oh, darn it. It's kind of tricky to get down at first, but you just click the trigger and it'll shorten up your wire. So now I'm going to weld a bead. Alright, and this is what it looks like before you get the flux off the top of it. That right there. Now, what you do now is you get you a wire brush, and it even's got like a, I think this is called like a little flux hammer thing. But you take that and you just kind of beat the flux off if it's on too thick. A lot of times you can just get it off by scraping it with the wire brush. Take the wire brush and you just basically just scrub all the flux off of it. Now my wire speed was a little low. I was experimenting with turning it down some. So it's not at the normal that I weld at. I usually weld on 4, and I turned it down to 3 to see what it would do. Now here's what it is on what I normally weld at. Let me put this right back. Alright, this is on 4. Now, as you could tell there by the sound of it at the beginning, the one thing that I hate about wire feeds is this cord right here. Sometimes it'll get twisted up. It's got a I can't remember what it's called. It's kind of like a coil that goes from here all the way into the welder, and that's what your wire goes through. Sometimes that'll get a kink in it or something, and it won't let the wire come out as good as it should. But let's see how that did. Maybe that did better a little bit. Alright. There's before the flux. And here's after the flux. As you can see, it's a little bit better than the other one, but I think my wire's not wanting to come out good all the way. So let me try to mess with it a little bit, and I'll show y'all. Sometimes your lead just gets coiled up some, so you gotta just kind of turn it around like that. Try to work it out of it. Yeah, alright, I think I got it. One thing I do like about gloves is it does help against putting your hand on hot metal. But I've kind of gotten used to hot metal at this point. I have, over my like 9-month welding experience, or working at a welding shop, I've kind of grown accustomed to hot stuff hitting. So, first time welding, you know, you got the slag flying out everywhere, and you know, hit your hand. The one thing I've learned is don't freak out. Pain is temporary. But here we go. No, it's still ding. Let's try it. Alright, before the flux comes off, and after the flux. Now, as you can tell, that is a little bit cleaner than before. One thing about welding helps, sometimes they'll creep down on you. But another thing I've learned, this exhaust pipe, so this is like an 1/8 inch thick. a lot of times you'll burn holes through it. And those are easy to fill in if you know you're pretty good at welding. But one thing that I know quite a bit about is your welder has a little chart inside of it. Right in there. That chart comes in handy a lot at telling you what voltage you should have it at, and sometimes even what wire speed you should put it at. Alright, so that, well, I reckon I'll demonstrate blowing a hole in something. I've got some thinner, this muffler right here is made of thinner material. I can blow a hole in that for y'all. So I do that now. Trust me, this will happen more often than not if you're not careful. That's what'll happen. And you can fill that in pretty easy. You just kind of got to go around the edges of it a little bit. Like, just put a tack down, then stop, wait for it to cool down a little bit, put another tack down, stop. And what that is basically your welder's burning too hot and it's melting too much of the metal and your wire will push through it. Now, a lot of times, I've heard this, but I'm not sure. I haven't really seen it, but I've heard that flux core gets better penetration than MIG does. So some people prefer flux core over MIG for that reason. I prefer it because I don't have the money to buy gas for the welder. This is a flux and MIG welder, so I could hook gas up to it. That's what this stuff is right here. Like, I've got the hose for the gas, you know, the hookup for it, will stand for it. I could put gas on the sweater, I just don't. I just buy flux core wire. The difference in prices, solid core wire for a MIG welder is like $8, and flux core wire is like $23. But a cylinder of gas, I don't know, I've kind of looked around at it because I did want to put gas on this welder and make it MIG, but it's all more than I make. So I mean, you can get you can get like a little here. You can get little bottles probably about like that big for it. It's like $100, I believe, or you can get bottles that are probably about up to here to me, and those are the only size bottles that you can own is up to here. They make some that are like this tall, but those are illegal to own. You have to rent those. You can get that from, you know, anywhere that sells welding gas, shielding gas. You can rent them. I can't remember the price. Renting a big one, I want to say it's like $30 a month, and you don't have to use all of it. It's just $30. You rent it, hook it up, then whenever you get done with it, you take it back. So it'd be handy, but I just don't want to fool with gas. Another reason a lot of people prefer flux core over MIG is the fact that with MIG, the way the gas works is a lot of people use, I believe it's 75% carbon and 25% argon. Well, that's heavier than air, so it floats it down and just covers the weld, pushes all the oxygen away. Well, what about when you're welding upside down? You have to have a gas that's lighter than air. So instead of having to get 2 bottles of gas just for one thing that I'm doing, I use flux core because the flux coats it no matter what. weld it normally, I guess that's called, you weld it upside down, down the side, it doesn't really matter. The flux is going to cover it. Whereas you weld it like this with MIG, you have to have a gas that's heavier than air. You weld it upside down, you have to have a gas that's lighter than air. One thing with MIG though is, or not MIG, one thing with flux core though is when you're welding upside down, you kind of have to watch your puddle, make sure you're not burning it too much, because sometimes the flux will just kind of puddle up and fall down. And I've had that happen. You don't want a puddle of molten metal about that big falling on you. That's not going to be good. In my next video, I'll talk about stick welding. I've never welded TIG. I'd like to talk about that, but I've never welded it. I basically know how it works. I can probably squeeze it in on this video. How TIG welding works is it's like stick welding kinda, except instead of using the welding rod, I'll show y'all welding rods in the next video. But basically what it is it's a rod that has metal in the middle and flux around the outside of it. You can get different size rods for different things. But you have a rod, a filler rod, and you have something like this, but instead of having a wire, it's not a wire feed. Instead of having a wire, it's kind of got like a little, like, pin type thing. I think it's called an electrode. And what you do is you'll put it down on there, and the arc will start from the electrode inside of here, and you take the filler rod. The arc will melt the metal together, and the filler rod just kind of fills it in. I believe the filler rods have flux on them too. I'm not sure though. I've never TIG welded. But TIG welding is for when you want to get more precise stuff. When you're welding something that needs more precision, you would use a TIG welder if you have one. And the difference between MIG gloves and TIG gloves is MIG gloves are thick to provide insulation from the heat. TIG gloves are thinner, like a lot thinner, so that you can get more precision stuff, or so you can weld more precision things, and they're just kind of easier to use. But they don't provide very good heat insulation. In my next video, I'll talk about stick welding. So that's it for today. I'll see y'all in the next video.